as I've said, because complex numbers are two-dimensional, so in fact, all numbers are really two-dimensional. It's just the vast majority of numbers that we've dealt with up until now, the real numbers, are just lying on that one-dimensional plane. They don't really do anything interesting. As soon as we add that second dimension to it, we can start to see some interesting things which happen. Okay? So, consider this.
And those things will be as simple as example.
Well, they might be. I don't know. But even so, I mean, Erdal, you said right at the very beginning that, I can't remember exactly what you said, but you said something like you didn't really understand why they were used in real life. Was that something like that? This is partly getting to answer that question. Okay? So, let's have a think. I'm not going to do addition. I'm going to look straight at multiplication because I think that's the most interesting one. Okay? So, I want you to think about the one-dimensional number line, so the real numbers. Okay? If I took, for example, the action multiplying by 2, okay? What would this mean geometrically on the real number line? So if I took every number and I multiplied by 2, what would happen on the real number line?
I mean, it will be stretched by 2.
Good. So the action multiplying by 2, with the real numbers this is, okay? If I multiply by 2, this corresponds to a stretch with a scale factor of 2, okay, with a centre at the origin, if you like. Now, all the centre at the origin means is I'm literally just putting my finger at the origin and I'm grabbing hold of the number line and pulling it out by 2. Let me show you what I mean. So I'm going to multiply by 2. See, my multiplier is up at the top. And what I'm literally going to do is just stretch the entire number line, okay? So you can see every single number is now twice as far away from where it was before, twice as far away from the origin as it was before. So for example, you can see 1, okay, the distance between 1 and 0 was that. On the new space, it's twice as big, okay? You can see 2 has now been made twice as far. Okay, 3 has now been made twice as far. Does that make sense? And the same in the negative direction as well. Negative 1 was there, it's now been stretched twice as far. Negative 2 has been stretched twice as far. Negative 4 has now been stretched twice as far. Negative 3 is twice as far. So what the action multiplying by 2 does, it's a stretch. It's literally saying, what happens if I put my finger at that point there and stretch the entire number line outwards? That's literally all that happens. So multiplying by 2, don't think of it as 2 times 5 or whatever. Think of it as every single number has been made twice as far away from where it was before. Twice as far away from the origin as it was before. Okay, and again, multiplying by 3, you're literally just stretching that thing out. Can you see that? You're happy. Okay. So this is what happens with the real number line. Now what happens if you put the second dimension in there? What happens if you also put the complex numbers? Okay. So if you're just dealing with the one-dimensional case, the real number line, you're happy you just get that stretch. What happens if you also look at the second dimension, the complex numbers, the real number, the imaginary numbers? So let's have a look. Has anybody got any ideas? So still stretch, yeah?
So you not like this, but like...
Ah, interesting. So it's no longer happening along the line. You're saying it happens at a kind of diagonal.
Yeah.
It's a good idea. It's a good idea. Shall we see? Okay. So I'm just going to use the number 1 plus I. I'm going to use the number 1 plus I. So I'm going to see what happens if I multiply by 1 plus I on the complex number plane, the complex plane. Okay. So the way which I'm going to think of this is I'm going to look at what happens to 1, okay? And what I need to do is I need to move 1 to the point 1 plus I. Now can you see that there's been a rotation which has happened here? So I've literally had to rotate so that it now matches up with the 1 plus I.
What?
Right? So have a look. What I'm trying to do is make 1 move to 1 plus I. Okay? Now, by doing so, just like I did with the real numbers, I had to move the entire number line to do that. Okay. What I'm also going to have to do here to make this point match up with this point is move the entire complex plane. Yeah. So I'm going to have to rotate the entire plane so that it is now orientated in the same direction as 1 plus I. Okay. And then I'm not quite there. I'm also going to have to stretch outwards. Does that make sense? So actually, multiplying by 1 plus I, there's not just a stretch which happens. There's also rotation as well. Okay? And now you can see that any number, when I multiply by 1 plus I, you're looking at this new position when I've done that transformation. Okay? So as an example, if I reset that, as an example, look at the number, shall we say look at the number 1 minus I. Okay, look at the number 1 minus I. Follow that point there. See what happens when I multiply by 1 plus I. So first of all, I'm going to do my rotation. Okay, so I'm going to do my rotation. So it's there, 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 there. Okay, so it's there. Okay, so at the moment, that point there is fixed at the old place which 1 was. Okay, it's fixed at the old place which 1 was. Does that make sense? Yeah, because
Wait,
1
show it
is the
again.
same position. Yeah?
So we are,
So fix that point there.
yeah.
Okay, when I multiply by 1 plus I, I'm going to do it in parts. Let's first of all do the rotation. So when I do the rotation, then I end up at the same position which the old 1 was.
True, yeah.
Okay, now I need to do the stretch. Okay, now the stretch which I'm going to do is the same as the length of 1 plus I.
Ah, now makes sense, okay.
Yeah, so I'm going to stretch the entire plane the same length which 1 plus I is. Okay,
Yeah.
and I can work out what the length is in just a second. Okay, so my point is there, remember, that's the point I'm after. It's currently sitting at 1. What I'm now going to have to do is do that stretch. So I'm going to have to stretch it outwards. Can you see that? So it's now there. Okay, so it's now there. So I need to work out where that new point is. I need to work out where that new point is. Okay, I can tell you where it is. Okay, it's going to be a little bit more than 1 because that point there matches up with that point there. So I'm looking at the new position relative to the old position. That's what I mean by when I multiply by 1 plus I. So I'm going to propose, I started off with 1 minus I, didn't I? That's the number which I started off with. That's the number I asked you to follow. When I multiply this by 1 plus I, okay, let's see what I get. Okay, I'm proposing it's going to be a real number and it's going to be a little bit more than 1. In fact, what I'm proposing is that the answer is going to be root 2. Can you verify this for me? In fact, no, I don't mean root 2, do I? I mean 2. So I'm proposing that the new position which it ends up with is going to be 2. But can you verify that for me? You happy? So you should get 1 times 1, which is 1. You get minus I plus I, which is 0I. And you get minus I times by I, which is minus I squared. I squared is equal to negative 1. 1 minus minus 1, there's your 2. But you can see, what I mean from it geometrically is if you look at a point, let me reset this. You look at a point, I asked you to look at this point. When I do my multiplication, in this case I'm multiplying by 1 plus I, what I'm actually doing is making this point match up with this point. So there's a rotation which happens, and then there's also a stretch which happens as well. I haven't quite rotated enough there. Okay? And then wherever my old point ends up, with respect to my point where it was before, okay, is what the answer is going to be. So you can see that this point here was the point I asked you to follow when I did that rotation and then that stretch, and it ends up at the old position of 2. So in other words, you take 1 minus I, if you multiply by this, you do that rotation and that stretch, you end up where the old 2 was. Does that make sense to
Like
everyone?
all 2, what do you,
So before I did the transformation, this is my original number plane.
yeah?
Yeah? So 2 was out here, and this point ends up at the old position
Oh, okay.
where 2 was. Does that make sense?
I see.
Yeah? So in other words, when I multiply by a complex number, in this case I multiply by 1 plus I do a stretch, same as before. But the new thing which I do is also a rotation as well. I also do a rotation as well. Now the question is, what do I stretch by? And what do I rotate by?
I think there not many explanation. Usually, if you use delete here, but it goes like this, and the rotation will be the angle of the 2 lines.
Yep. So it'll be the angle. So if I represent 1 plus I on the complex plane, Okay, so this is my real part, and this is my imaginary part. Here is 1 plus I at the moment. Let me draw a line in to show that a bit more clearly. That's 1, and that's I. Okay, this is 1 plus I at the moment. What I've done here, is a rotation. Okay, and the rotation which I've done is the same angle which 1 plus I is relative to the real number plane. I've also done a stretch as well, and the stretch which I've done by is the same length as 1 plus I. Does that make sense? Yeah, so whatever that length is, I've also done that as well. But all I want you to take away is multiplication is only, so you thought before multiplication was just a stretch. Half true, okay? It is a stretch, you still get a stretch, but when you deal with complex numbers, in other words, those two-dimensional number lines, okay, two dimensionals, you also get that rotation which happens as well. It's just before we didn't see that rotation because it's just in one dimension. We didn't have the opportunity to turn at all. We were just doing the stretch part. Does that make sense? Mm-hmm. Yeah? So multiplication is a stretch, except when you're dealing with complex numbers. You also get that rotation which happens as well. And it's that rotation which is the really interesting and useful thing about complex numbers. Okay? So we'll talk a little bit more about the uses in future lectures, so we move online. Okay? We'll talk a bit more about the uses, okay? But the important thing which I want you to take away from today is that when you do multiplication, okay, you do still get that stretch, but you also get the rotation as well. That's going to be really key moving forward. Is that okay? Questions?
Your starting point is 1.
Yes, because you always do it relative to 1. So you say, I wonder where 1 is going to end up relative to the old positions. Yeah? And I can, yep. So you do that because you remember, in fact, if I show the original axis underneath, it might be a little bit easier to see. I can move this point to be whatever I want. So let's say, for example, I move it to be, let's go there. Where was it? 1 plus 2 plus 1.4, I think, I. Okay? So if I do that rotation and that stretch, I'm basically looking at where the number which I followed, I'm looking at where it ends up relative to the old number line. Okay? But I always have to do it from the perspective of 1, because if I multiply by 1, what do I end up with? Itself. Yeah, I end up with itself. So if I multiply 1 plus 2 plus 1.39i by 1, it should be that 1 ends up at that position. Because if I multiply by it, I get that number back.
Wait, I'm confused.
Okay, what are you confused about?
Like, why are we multiplying with 1?
Okay, the reason why. So Sophia asked a really good question. She said, why do we always have to look from the perspective of 1? Why do we always have to look at where 1 ends up? Okay, well, think about it. If you take, so I'm multiplying here by 1 plus I, we've just seen that if you multiply by another complex number, for example, let me do it a different colour, if you multiply by 1 minus I, okay, you end up with something new. You end up with 2. And that makes sense because clearly 1 minus I doesn't get mapped to itself. Okay? But look what happens if you multiply this, 1 plus I, by 1. What happens if you multiply 1 plus I by 1?
You have itself.
You get 1 plus I. So in other words, what I'm saying here is that when I do this multiplicative action, so I do this stretch and this rotation, if I look at 1, it should always end up at the thing which I'm multiplying by. No other number is going to end up at the same position which I'm multiplying by. Does that make sense?
So,
Sorry?
so that's why we are looking for...
That's why we always look at where 1 ends up, and then we can do the rotation relative to what happens to 1.
Oh, okay. So when we rotate it, the line wouldn't, the line wouldn't change. So we have the same line when we rotate it.
Yeah.
I see.
So the reason why we're looking at 1, so we say, the reason why we look from the perspective of 1 to understand the rotation and the stretch is because 1 will end up at the same position as the thing which we're multiplying by. Always. Yeah, no other number. So for example, 1 minus I ends up over here at 2. Yeah? What else? 1 plus I ends up here at 2i. Okay? What's this? I ends up at negative 1 plus I. Yeah? So all of the other numbers end up at a new position. Okay? But they're always done relative to this rotation and this stretch. go away and have a play with this. Okay, so if you're interested in playing with this, let me hide this down. Okay, go to my GeoGebra channel, which is Maths Partner. Okay, and just simply type in numbers. Okay, just simply type in numbers, and I've got all these things down the left-hand side. Okay, so I'm playing with multiplicative action on the complex plane here. You can see what happens with additive and multiplicative actions on the real number line. Okay, you can see what happens here. That's what I was playing with before. So again, if I multiply, do the multiply one, you can see that what I'm multiplying by, you're seeing what happens to 1. So, okay, so have a play around with this. You can even do negative to get those reflections as well. Have a play around with this. It's not imperative that you understand it, okay? But I'm just showing you that complex numbers are quite cool. Okay? Because they're two-dimensional numbers, right? You can understand or you can see some really quite cool things happening. So rather than just saying, oh, I'll multiply a number by 1 plus I, and you do it and it kind of falls out and you go, yeah, but so what? You can actually see there's some really cool things which happen if you understand the geometry of it, okay? So if you take nothing else away from today, like if you don't understand this in full detail, but you do understand that when you multiply by a complex number, there is a stretch which happens and there's a rotation which happens, I think you're in a pretty good place.
Are you